Oh, God. Opportune time to cough. Hello and welcome. My name is Layla. Thank you so much for coming to join me. And we are going to be talking about Distribu-ready with the Modular Monolith. So I really enjoy talking about this topic. I've spoken a lot about it over the past 6-7 months. And I've been working on Modular Monolith for more than a year, trying to figure out the best ways of doing it, doing lots of research, and that's how I came to this talk, to share that knowledge that I've been accumulating. This isn't the definitive guide. This is a way to approach it, to give you some ideas with all types of architecture. You can't just take it as is. If you do, you're going to come up against problems, and that's when you become dogmatic. So I like to always be pragmatic, and you'll see that repeated throughout today's session. Just as a point, I may need to sit at some point, okay? I can totally sit and still present, so we'll see how I go. But if I have to sit, I apologize, but I got to do what I got to do. Alrighty. So, as you know, I'm Layla. I'm not anything. I'm not employed. I used to be a developer advocate. I'm an architect, a .NET developer. I make YouTube content. I haven't for a while because I've been very sick. And I enjoy learning all the time. I'm currently learning to be a game producer, so I'm on a course learning to do game production. So I love games and building games, and I'm working in Unity as well. So if you want to chat to me about that, we can do that after the session. So let's go and have a look at what we're doing here. Oh, now you wake up. Okay, let's go. Okay. It was awake a minute ago. It just buzzed in my hand. There we go. Is it coming? I literally just tested this. 1 second. Let me just get the Bluetooth up and make sure. Typical. If not, we will just ignore it. No, system. Okay, fine. Fine. I have arrow keys. Yay. If in doubt, the arrow keys. Okay, so there is a content warning with this. I had a lot of fun with AI-generated imagery. It does get very weird, and I just realized that I forgot to include the Slido link. So if you know what the Slido link is, you can go to it. I'm really bad. Okay, so it does get really weird, so just bear with me. All right. Now, I really want you to think about this statement from Richard Branson. Complexity is your enemy. Any fool can make something complicated. It is hard to keep things simple. Okay? There are some seats at the front if you want them, and dotted around, so feel free. It is really easy as software engineers to come along and start adding in this framework, this project, this NuGet package, and just start to add in all these additional levels of complexity, okay? So to keep things simple is to actually have to think about what you wish to achieve, maybe to learn a little bit more about something, and then apply it to your situation. And that is sometimes hard. Maybe you don't want to learn how to actually do something yourself. You just want to go and get the library, but now you've got a dependency on that library. Are they going to maintain it? Are they going to update it? Are they going to add breaking changes, et cetera, et cetera? So sometimes it's better if you do things yourself and keep things simple. And also, sometimes it's better if you don't do, as I like to call it, CTO-driven development. I always imagine a CTO at the golf course with other CTOs listening to the other CTO and saying, oh yes, we just implemented microservices, have you? And that your CTO is going, no, but we're about to. Yeah, we're totally doing that. And they come back into the office after their golf. They're a little bit red from all the sun. There's you chained to your desk. And they're going, we're doing microservices. I just told my friend we're doing microservices. And you're like, we are? But we only have 100 customers a day visiting the site. No, we're doing microservices. And so we see that type of thing happen quite often. Or you'll have your lead developer, they want to move on, they're a bit bored, they want to learn something new. So they'll do CV-driven development. And they'll be like, okay, folks, we're going to do microservices because I really want to try it and put it on my CV. Again, this is not great. I had a team lead who implemented Hatios in one API. Okay, rather than doing a spike on a separate branch, he just implemented Hatios on one API. So a totally different way of doing your API endpoint, okay? And then decided, no, we're not going to do that for the rest of the APIs, but I'm not taking that out. I'm just going to leave it. So we had one single API in amongst all the others that implemented Hatios rather than standard REST. And it made me very mad. I only stayed at that company for about 2 months because I was like, this is ridiculous. The program manager really doted on the lead developer. He's like, oh, he's brilliant. And I think, no, he's an idiot. But anyway, so I want you to think about all these reasons why you might try to do something different. And as I'm going through this talk, think, do I really need all of this, or can I take a little bit of it? So trying to keep things simple is something I really try to tell people to embrace. Okay, so many of you are familiar with a monolith, and you've already heard me mention distributed systems quite often, and that is a monolithic rock. It's a single rock on its own, and then we have a distributed system of rocks. The sarsen stones do have linking stones on the top, and it's kind of very reminiscent of a distributed architecture. So I always like to pop this in. So we're used to these now. We're very familiar. In the .NET space, I think we've been talking about distributed systems or microservices for the past 7, 8 years. It's been much more prolific. So let's go into those a little bit more detail. Most of you should be familiar with monolithic architecture because that's what we generally start with. When we're learning and building our first application or our first job, we usually start with a monolith. Now, it means that everything is in a single project. Everything's quite tightly coupled. It runs on a single server with a single executable. It's very easy to develop. Everything is there. You can go into your IDE and just press play, and it plays. You don't have to start lots of different things. It's generally easy to understand. It's easy to debug, because you can just put a breakpoint in, and somewhere in there it will hit it. Okay. The problem comes when you want to scale it, and possibly when you want to maintain it, because sometimes these things get very mixed up. You don't always have the same people working on the application. You maybe don't have the original architect or the original developer who architected the whole thing. And as new people come in, they just go and add something in. And maybe you've got the same type of functionality in multiple different places. And it starts to become quite tangled. And that's generally what is then termed as a big ball of mud, or a BBOM. You might have heard of that. Now, that doesn't mean that all monolithic architecture is like that. You can have really beautifully structured monoliths that are well maintained and are a joy to work on. It's all about how you keep them in order. And that goes for distributed systems as well. You can have distributed big balls of mud. Joy. That's a great place to be. So microservices architecture is where you have lots of individual executables. They're all small and independently deployable. Now, they don't necessarily have to be small and in only a few lines of code. People often ask me, well, how big can my microservice be? It needs to be as big as it needs to be to do its single bit of functionality, okay? They need to do one thing and do that one thing well. Just like when you are making a method, you want to bear in mind that single responsibility principle and just have that sort of single responsibility on a macro scale for your microservice, okay? But the problem with microservices and distributed systems is you have a lot of individual executables. So you have to run all of those. You maybe have lots of services, maybe multiple different databases. You may have message brokers, caches, gateways, all these different services that to develop locally, you need to emulate or run or can run in a container. You as a developer have to have all of these things locally in order to develop and debug. Debugging is horrible in distributed systems because it's all like, where is it coming from? How's it going to come in? Oh, to get this to work properly, I either have to mock this or have it coming in and running locally and things like that. So they can be really tricky. So we get to the point of needing something. And it's usually to scale and meet incoming demand. That CTO is actually not an idiot, and he comes in and says, okay, so we're doing great, folks. We have so much business coming in, but I can see on the load on the servers is really high, and we can see people are leaving because X, Y, and Z. So how are you going to scale to meet this growing demand on your successful business? So you may think that your options are your current monolith, scaling it, putting in some monitoring, tracking where the bottlenecks are, and eliminating those. And maybe you'll scale horizontally, or maybe you'll scroll vertically, so that's throwing more compute at it, or horizontally, you might have multiple instances of it, okay? And then you'll need some kind of load balancer, and that adds some complexity to it. Or you will go down that route of distributed systems, break the app into individual services that can scale individually. So perhaps you have an order service, and you have peak times of orders, like say a Black Friday event, and you can scale up that order service to meet that demand and then scale it back down. And you have that independent control. You don't have to scale the whole system. So those, may be your immediate options. So just to compare those two, local development is much easier on the monolith, but everything else appears to be solved by distributed systems. And this is why a lot of companies will do early adoption of distributed systems, because it looks like it solves all your problems, right? You look at this and go, yeah, it's flexible. All my services can be scaled independently. I can deploy them frequently. We can get those new features out to our customers much faster. And just for a little bit of difficulty for the developers working locally, we're winning, okay? So a lot of companies have gone down this route of going into microservices or service-oriented architecture, SOA, if you've heard of that, which is kind of similar to microservices, but you have reusable services, and they're shared across multiple applications. Same issues, though. So you'll have a lot of people going this way. And what I've been hearing at my previous company is we were having a lot of companies wanting to pull back from distributed systems and recompose all of their services into a monolith. So people were doing this too soon, and it created too many problems for them. All right, so yes, it sounds straightforward. All your problems will be solved by distributing your applications. But they do come at a cost. Remember our quote from the beginning? Simplicity is that cost. Microservices are complex, okay? They are so much harder to do. So let's have a look at some of the reasons why and our journey to distribution. So I love this chart. I stole it from a former colleague. He stole it from someone else. He stole it from someone else, but it's mine now. So we think we have our monolith, and we're just going to go to our microservices, just like that. Looks really straightforward, doesn't it? Nice straight line there. Who thinks that's the reality? Yeah. Now you're going to end up here, a distributed monolith. This is a very, very bad place to be. Now, that's not to say you won't somehow arrive or go via the distributed monolith on your way to microservices. As the saying goes, you have to break a few eggs to make an omelet. And sometimes when you are re-architecting an application, things get ugly. They get a lot worse before they get better. But there are dangers of the distributed monolith. I did warn you that, AI is a little bit crazy. I asked it, show me a dangerous distributed monolith. Okay, that's what we got, alrighty? So I'd be pretty scared of that. If that crawled out from behind my desk, I'd be like, whoa, I'm out of here, okay? So it is a difficult place to be. So what exactly is it? This is quite a simplistic example. The most common thing people ask me when they're going to, one of the common things I'm asked is, do I really have to separate my databases? Do I really have to have a database per service? Yes, you do, okay? Because this is what happens if you don't decompose your data into multiple databases. We've got two services. Both have a dependency on the single database. Now, we need to do an update on one of those services, all right? So we'll do a migration. We might change the models and all those sorts of things that you might do when you update a database. But what about that second service? Now, if you want to release your changes to that other service, you're going to have to do that to the other service. You've coupled these services. Now we've got our little application one and our database, and the second application is coming along too, okay? Again, gotta love AI for the stuff it comes up with, okay? So you have now got a coupled system, and that's one of the reasons you went to distributed architecture. You wanted to decouple everything. You wanted to be able to independently deploy your services. Well, you can't do that now, I'm afraid. Tough. So developer life just got hard. It's a sad developer from AI. You have all of the complexity of a distributed system, but you don't have any of the benefits of those independent, discrete services, okay? And you have none of the ease of monolithic development and debugging, okay? It's really just, you see why I said it's not a good place to be. I'll pop that down there. If that goes clunk, I apologize. Okay, so we need to think about this golden rule, loose coupling and high cohesion. And this is an old software engineering ideal. It's just still as important today as it was 30-odd years ago, okay, or longer. Now, this is something that we'll come back to, so I want you to keep thinking about this idea of loose coupling and high cohesion. So those coupled modules that we saw, those coupled services had tight coupling, okay? So we want the more pleasant journey to our distributed systems. And how do we do that? So remember this diagram. Now, to get to our microservices, we're going to go to a modular monolith. Now, you can stay in the modular monolith for however long you want. You can stay there forever if you like, but if you do need to go to a distributed system, it's much easier if you've gone the route of the modular monolith rather than the distributed monolith. So I always think, well, this is a popular little meme, so we really want to be on the modular monolith path because, you know, I'm an advocate for the modular monolith, so we definitely do not want to go down the distributed monolith path. You'll look sad, and I don't want you to look sad. All right, so let's go back to this diagram here. We've now got a third option. Yay, the modular monolith, the best of both worlds. Yeah. And a lot of the problems of both worlds, okay? It's not all plain sailing, I'm afraid. It's got a lot of the problems of both a monolith and a distributed system. So maybe I've just half sold it on you, and now you're thinking, whoa, it's got problems of both. Why are we here? All right, well, let's go and delve into this deeper. So a modular monolith application is where we have loads of modules, okay? They are very high cohesion within each module, but each module is loosely coupled with the other modules. So we're thinking of that distributed system, but all in one code base. Technically, you could take a module out and swap it for another. That famous thing is like, why do we do iRepositories? So we can swap our repositories out. Same principle. You can have your module, and you could swap it out for another one. Unlikely to happen, but you could. Okay. And so I would like to introduce you to the KitKat pattern. It's my own devising, and you are welcome to adopt it. I encourage you to adopt the KitKat pattern. So I have a question, and I need you to answer me honestly with a raised hand. Who eats a KitKat like that? Go on, don't be shy. Okay, you back there. Monster! Singling you out. I can half see you beyond this light. Okay, you're a monster. You do not eat a Kit Kat like that. What are you thinking? You break them off and you nibble all the chocolate and then you eat it, okay? It's how it's done. So I'd like you to think of your software like this, okay? It's like an entire Kit Kat bar. And each finger represents an individual module. You can see it's all encapsulated, they're related, but they are separate, and you can break a finger off into a self-contained module in your application, okay? It's a self-contained thing that you can break off. And now you're going, how does this all work in my application? And we're going to start delving into architecture and how you can actually structure this and implement this in your .NET application, all right? So this is your plain old monolith. I've gone with end tier, but you don't have to go end tier. You can choose any of your I don't know, they keep coming up with new names, maybe, you know? All right, so you can choose any of those. I don't care. You can apply these principles to whatever architecture you're doing this week. All right, so we can slice it up vertically or in a spiral or whatever works for your application. You'll figure it out, but thinking with end tier because it's simple and most people have done end tier. We're going to divide it up into these vertical slices. Now, it is similar to vertical slice architecture, but they are not the same. So vertical slice architecture would take each feature and do that as a vertical slice, but that is applied to monoliths, distributed systems. It's not the same as a modular architecture, but it does have some parallels, okay? How do we decompose the application? Now, I'm going to assume you've got your monolith, your standard traditional monolith, and you want to do that path towards distribution, okay? So again, we're coming back to that loose coupling and high cohesion. This is really a core principle that you need to maintain, all right? Elements within a module have to have high cohesion and be tightly related to each other. Okay, so anything that is very similar needs to be in that same module. Anything that isn't similar needs to be loosely coupled. So all of our modules need to have very little coupling, all right? We want to be able to write code in one module without having to go and write code in the other. So cohesion versus coupling, I'll just give you a few moments to read that. This is just kind of how you can get that, all right? So we really want to have as loose coupling as possible. Alrighty. So how do we do that? We're going to start incrementally with the largest chunks possible. We're doing this just with like an e-commerce site as an example here. So we've got our orders, inventory, notifications, dispatch, all right? You know, if DDD is your thing, go that way, okay? I really don't care. It's the big picture I'm going to show you here. Keep it simple, though. It really pays to be as simplistic with it as well. So we want large chunks because you can further decompose those large chunks. And the other modules don't actually need to know that you've decomposed these chunks further, okay? You can keep modules within modules almost. So it's very flexible. Okay, so again, that pesky database, we spoke about that earlier and decomposing. So we're not going distributed. So do we need to decompose the data? Well, let's have a look at the options first. So code first. Okay, we start by taking the module out. So now we're coupling the existing monolith and a module with the database, okay? Now, this is fine. Sorry, it's my earrings rattling there. I should have taken them out. Or we can go data first, separate our data, and then take the module out second. Now, what is the difference between these two? All right. Now, this really is down to the functionality that you're extracting. If you think the data is going to be a pig to separate, it's going to be a nightmare, and you are dreading separating and decomposing that data, do the data first. It may be that your approach won't work, and then you won't have gone and separated your code first and then come to your data and gone, oh, yeah, this isn't going to work. If you think your data is going to be easily decomposed, go for your code first. You'll feel happier about it unless you're a database whiz kid, then do whatever you like. But generally, you'll see much quicker results if you take that data out, that code out, and then do your database. So those are our options. However, if you do end up taking your module out and sharing your data, it is still a monolith. So I'm going to say this, even though it pains me a little bit, this is okay. That hurts. To say, do we actually need to decompose the DB? No. You need to be pragmatic, not dogmatic, all right? But what you do need to know, if you are not decomposing that data straight away, is that you've now accrued technical debt, all right? And as long as you know that, that's okay. If you come to take that module out and distribute it, you are going to have to take that data out and distribute it too, okay? So you can leave it like that, but know that you're going to have to do it at some point in the future. All right. So this is the question. How is this Distribu-ready? Now, if you remember our Kit Kats, a finger can be broken off, and in turn, it can be treated like its own chocolate bar, just like a module in your application. Now, DHH came up with the Citadel pattern. I don't like that. That doesn't resonate with me. So I came up with the satellite pattern, okay? And this makes so much more sense. Our satellites orbit the big bodies, okay? So we have a central, not necessarily modular monolith. You could do this pattern with your regular monolith. And then we have self-contained modules that can be broken off and become satellites. So if we have our monolith, this satellite application is self-contained and can be distributed. Okay? They can be standalone apps. They can be containerized. They can become serverless functions. That means that they can be scaled independently or scaled down to 0. So a classic one is a notification service. You may extract that out, and if you're going to send out 100,000 emails and text messages, you might scale that notification service up for the period that you're doing that, and you can also queue things up into it, so it all works really sweetly like that. And then once you've sent out your mail shot, you scale it back down. Okay, so it's really a lovely way of working. And when you've got your modular monolith, it's very easy to start snapping off those modules. So it leads us to an important question of how. So I have spent many years building an application, so we're going to go through how we do that. The main questions we need to think about as we're doing this: how do we ensure the modules remain completely independent? This is really key. They have to be loosely coupled. How will our modules communicate, and how do we enforce the architecture? All right, so the project I've been working on for a long time is Tacky Tacos. This started life 4 or 5 years ago, and I've been working on it all that time and just building it up. So its current state as a modular monolith looks like this. We have a client, we have web API, and then we have our logic. And then those are our modules within it. Things to note: the client app could be standalone and could even be distributed on a CDN. Then we have a web API layer, and that's going to extend the endpoints from the modules. All of those modules still have their self-contained API endpoints, because if we want to distribute them, they need to already be self-contained. And then we have our logic layer, and all of the modules must abide by strict intercommunication rules set out in a contract. All right, so this is our actual projects. We have the web API. We're going to ignore the front-end client for this now. We have orders, and then orders tests, and then we have all the contracts. Okay, they're just class libraries, and they have like DTOs in them. I'll show you examples as we go. Now, the only project that can reference the top-level module, like the orders or the payments, is the web API. Okay, it needs to know what the API endpoints are. So it's the only project that can have the references to those big modules. Okay, everything else has to reference the contracts project only. That's how we're keeping this distinct architecture. So how does that enable our communication? Well, for the external communication, that's quite quite simple still. So let's think about the client coming in. We have REST, and then we can make a GET request to the web API, and then that routes through to the menu endpoint, or whatever it is, and that's where the logic runs. Okay. Same if you want to hit multiples, you could go through, you can combine them in the web API to go and hit those different endpoints, and you can do all of that. Now, the endpoints in a module, this is using minimal APIs. Do note that this is internal as well. The accessor is set to internal. That's important to help keep that encapsulation of the module. So we have our get and our post, and we are extending web application app. If you see the keyword this, means that I'm extending that web application there. Now, when I come to use this, I have a web applications extensions class inside my module. Okay, and that's where I can call my map order endpoints, that previous code. And then we can do the same with all of our services. So for our dependency injection, we can extend iService collection. Again, we've got this keyword. We can pass in configuration if required. You'd need that for a DB context. You'd want configuration, such as the connection strings and things like that. And then we've got those there. So how do we use this? This is now the web API, that top level application. And you can see that we have popped our payments module there, and we've got builder.services.add payments, and we're passing in our configuration. And we also have down here where we've added in our endpoints, okay? So we've got this nicely structured way of adding all of our functionality from our individual modules into the web API. Now, on those services, you could have extended iWeb Application Builder instead and done builder.add orders. That's entirely up to you. I prefer to extend iService collection. I prefer to read it that way. How you write your extension methods is entirely up to you and your team. This is just the way I've done it. So that seems pretty straightforward for external communication synchronously. We like to think of that as synchronous because we're expecting a request response. Now, inter-module communication. There's quite a few ways you can do this. Now, each module could have a public interface, and we can make a direct call between those modules. Yeah, sounds good, until you end up looking like this. We've increased the coupling, because now we're talking directly to those modules, all that intermodule communication, and that's going to be pretty yucky when I want to take that one out the bottom middle and distribute that. How am I going to talk to it, okay? It's not a very maintainable Distribu-ready way of working, okay? Because if we talk to it directly, which we shouldn't do, it's going to be a mess, all right? So how can we do that instead? First up, a mediator. So using your mediator pattern, and I'm not saying go straight over to use Jimmy Bogard's mediator. You can if you wish, but you don't need to. Learn how to implement mediator pattern yourself. It's pretty straightforward. And you can just go and do that. Now, the communication between objects is encapsulated within the mediator. They're not communicating directly with each other. So we've now decoupled those modules, and we've reduced the dependencies. So yes, good. The other way we can do it is messaging. Yes, we can use messaging inside a modular monolith. Now, if you're not familiar with messaging, we have one module that's a producer, and it's going to in-queue a message onto the messaging queue or broker, and then the consumer module will dequeue it. Okay? So in Taki Tacos, that could also be the mediator at the bottom. We send something through to the mediator, and then the kitchen consumes it. Okay? So we've decoupled everything. Now you'll notice that the message bus looks very similar to the mediator. So that means you could go mediator pattern first, and then at a later date, as need requires, you can upgrade to the message bus, okay? Because the pattern is very similar. Okay, so a design like this is called event-driven or message-driven. So if you want to learn more about that type of architecture, those are the keywords you can put in. So things to note is that the web API layer is the only executable. Not strictly true, you might have a satellite or a few other things, but generally speaking, the API layer is our single executable. So all of our producers and consumers need to be registered in the web API. Now, oh my God, it's not leaked into the power. It's fine. I'll just put that over there. Oh my God, I'm a disaster today. It's all over my foot. It's fine. I can have wet feet. No problems. Okay. So, forgive me. All right, so when we are doing these types of messages, there's a pattern that I do like to talk about, and that is different types of messages. Now, we can have thin messages and fat messages. People don't often talk about this. They just talk about the events, and we're just sending out all these events. But this is a really nice way of implementing your messaging pattern. Thin messages, they are like an event. They only contain necessary information needed to carry out a specific task. So they're, hey, yeah, this is done, okay? Or, hey, here's an ID. It reduces network traffic and processing overhead, and it can make your system faster. Now, on the other hand, we have fat messages. Now, they have a lot of data. They're a lot bigger. They can result in increased traffic, and they can slow down the system. But they are useful where you need a lot of data transferred. So I'm going to show you how that works in Taki-Taka, so you can bear this in mind for your inter-module communication. So I usually use my spotlight, but, you know, it's gone. I can use. Oh, it started. Thanks. Okay, let's go. All right, so at the top here, we have an order come in, and we have two API calls. One to the order module in the order endpoint in the order module, and then we have one going into the payment. Okay, so these here, this quoted one, orders.update.paid, is what we call a routing key. All right, if this is a topic exchange in RabbitMQ, which is a very popular message broker, this is a routing key. All right, so we're going to publish an orders.update.paid with an order ID. So this is a thin message. Then if we come over here, the orders is listening for anything that has an orders.update.star. It's a wildcard, okay? So you can see here, it's going to be listening out for this event. Now I'm going to call that an event because it's going to get the order ID. Now it knows that we've got this ID and it can mark it as paid. Okay. This is also listening for orders.details.request, so we haven't generated that yet. So if we come down here, what else is listening for stuff, okay? This one, the kitchen, is listening for orders.update.paid from the payment system, so it can go to the topic exchange when that's published and consume it. So that payment producer has two consumers, kitchen and order. Okay, so the kitchen is now listening for orders.update.paid. But do you think the kitchen can make your tacos with just an order ID? The answer would be no. It'd be a miserable taco because it wouldn't be what you ordered. So it needs to put out its own message. It's now a producer, and it goes and says, hey, I'd like orders.details.request for order ID, whatever it is. Okay, so that's another thin message and event. And if we go up to our order, it's listening for that routing key. So what it produces is an orders.details response with the orders details. So this is now a fat message, and that kitchen is listening for that orders.details response, which has all of the data that's in that order. Okay, so now it can start making your order. But the reason why we do it like this is because the order doesn't need all that data. The payment module doesn't know any of that data. So when you've got your modules, you need to really start separating your concerns. And this is where we've got that high cohesion and loose coupling in effect. It does make you have to think about what has knowledge of what, and what modules need the information. And also, who is the data owner? So the order module owns all the data around the order. So we have to go to the order module to get the order details for us to be able to make the food, okay? So it can be a little bit difficult to get your head around when you start, but once you start breaking it down, you can see how you can go through that. But we have now drastically increased the complexity of the system. We now have to consider error handling and implementation details of a message-based architecture, okay? So that is complex in itself. Okay. We have loosely coupled modules, though, and they are easier to convert into satellites. So you've got to weigh up which is the lesser of two evils for yourself. Do you want that Distribu-ready type architecture, or do you want to just have your easy to manage, more simple monolith? Okay, those are all decisions you'll need to make. Now, how do we prevent the inevitable of your application turning into this beautiful big ball of mud? That is the main issue with modular monoliths. How do you maintain their architecture? So there are several ways: code review, compile time, automated tests, and style guides. So let's go into these. Code review. Now that can be pair programming. There are so many benefits of pair programming. Sharing of knowledge, okay? It encourages open discussion. You can challenge each other's thinking, challenge the status quo. You can come up with ideas and novel solutions to problems. So it's really beneficial. However, it can be time-consuming, time well spent, but maybe not well spent looking at the structure of your modular monolith, okay? You want to be solving problems with that time of two people sitting there pair programming. But if you're pair programming and looking at it going, oh, hang on, we've coupled these two modules, that's not a good use of time, in my opinion, okay? It is slow. You have to wait for that person to be available, or maybe they're on vacation, okay? And the biggest problem I see with pair programming and code review for architecture enforcement is it requires the reviewer to know and understand the architecture themselves, okay? And that is the biggest problem. Okay, compile time. This is really useful and something that you can do yourself as you are architecting your system. Now, we adopt private by default. Now, remember I highlighted that we had internal for one of our things? We really control in .NET how we keep those modules tightly encapsulated by accessors, okay? We start at the minimum level of access, private, and then we slowly come up. If you are worried about how you test that, you noted that I had separate testing projects. You can expose internals two projects in your CS proj. I think I show you that in a bit. But you can have in your CS proj, you can say expose internals to X project as a reference, okay? So you don't need to write your methods public so you can test them, all right? So try and keep everything as low access as possible. It's really important. And everything is encapsulated into a project. A class library is going to be your friend. Okay, so each one of these is a class library. Everything there is encapsulated. So when we want to go through that private by default, we have our contract, and that is how they're going to communicate with each other or understand what the other is they're going to look at. This is our bounded context, if you've heard that shared surface that they're both looking at. Now, if we see it in practice, we have our order module and our kitchen module, and they're communicating via the message broker. Now, they have their contracts project, and the kitchen module is referencing the order contracts, so it knows the format of that message coming into it, okay? So it's like, oh, this is an order DTO. I know what that looks like. And then it can convert it to its own model, a kitchen orders DTO, or whatever it needs to do with it, and then carry on. And that's how our contracts work. And that's our bounded context. It's saying, this is what I'm giving you, the order module. This is what it looks like. And the other module can go, thanks, okay, I know what to do with it. I know what it looks like. So that's how you work on those contracts. Now, compile time is great because you get immediate feedback. That will say, no, you do not have access to this. But the drawbacks are you need to write your code with those accesses. You need to be diligent and make sure that you have things set to private, to internal, to protected, to whatever it needs to be. Yes, people always go, oh, it can be circumnavigated by reflection or the new unsafe accesses. Okay, I will die on this hill. If you are using reflection and the unsafe accesses to get access to protected code, more fool you. You should know what you're doing. If you're breaking these conventions, you're doing it for a reason, okay? That doesn't mean we shouldn't do it. The reason we're doing it for that is so we know what we should and shouldn't access. If you then choose to go and access that code using reflection, so be it. I can't hold your hands for it, but you know that you shouldn't be, okay? And then it's undocumented. So don't use those excuses not to write your code in a proper way. I've had big arguments with this, big arguments. Use your accesses. They're there for a reason. Automated tests. Yay, static code analysis tools and architecture tests. These are fun. So the static code analysis tools, these are great, all right? You can program them. They come in your IDEs. You can get separate things that you add in. You can get a whole big templates, customizable. So they're automated, self-documenting. They can do reporting. They just plumb into your IDE, even into your CI/CD pipeline. So they're such a great tool. And then the stuff that they detect, syntax errors and typos, SQL injection vulnerabilities, general code smells and anti-patterns, and then your best practices that you've implemented, okay? So they can do so much, and they're completely customizable with this weird type file thing that you can go and play with, okay? So we also have architecture tests. The benefits of these are they're automated, they're self-documenting like any test. You get fast feedback because you run them, they fail, you know you've done something wrong. And they have all the benefit of tests, but they're for architecture. They do take time and discipline to implement, and like any test, you do need good coverage. So this is an example architecture test. I do have a YouTube video on these that you can go and watch if you're interested, and I compare two libraries on there. So you can see that they're very readable, using a Fluent API in particular on this one. And we can see that classes that reside in assembly kitchen module should not depend on any types that do not reside in assembly order module. And then we check the architecture, okay? How readable is that as self-documenting? You can see exactly what it is. If you're coming to work on a project, you can go and read the tests and understand the constraints and rules of the system. So they're very worthwhile. Even if you're not doing a modular monolith, any application would benefit from these types of tests. Now, the last one is style guides, benefits, documentation, and it's a good resource for everyone to look at, okay? This is Google's style guide for C#. It's publicly available, so you can go and have a look at it, and you can see it goes into details like names of interfaces should begin with an I, and all of these different things. So that's one that you can use directly or adapt it for yourself. So to summarize the modular monolith, use where modularity is important, okay? Now, if you don't need to ever go distributed, you don't need to go modular. You can adopt some of the principles here and adapt them, but you can adapt those into your n-tier architecture. You don't need to go into the added complexity of a modular monolith. They are more complex. But where they are great is if you need that modularity, but you don't need to go fully distributed. But you maybe need to distribute a couple of those individual services, okay? So they're a great halfway house between the monolith and fully distributed. They're very versatile if you are getting to the point where you think, we do need to scale in some places, but not everywhere. Okay, so the key things to remember are, be pragmatic, not dogmatic, okay? Always try and be practical. Do not go and be dogmatic. I have had, it's that same team lead who put the Haitios in. I was learning test-driven development, and I didn't write all of my unit tests first. I sort of wrote a bit of code and, then did some tests, and he came over and goes, I know that you did not write your tests first, that you did them after you wrote your code. Next time you do that, I'm deleting your day's work. That's being dogmatic, okay? That made me very mad. He did a lot of things that made me mad. And it's not practical. To delete someone's day's work just because they didn't do TDD exactly how you want it, but you've still got your unit tests and working code is ridiculous, okay? So always try and be pragmatic. Be aware of the technical debt. You should always be aware of technical debt. It's so easy to accumulate. Every time you add a package into your application, you are accruing technical debt, okay? And if you're not decomposing your data, you're accruing technical debt. And then high cohesion, loose coupling. So we always want to remember these things, not just when designing a modular monolith, but any type of application. Okay, now for a question that you probably all want to ask, I'm sure it might be in some of your heads rattling around. Can I use .NET Aspire in a modular monolith? Yes, it's almost made better for a modular monolith than it is for a distributed system because it's a mono repo, and when it came out, it was only for mono repos. So yes, you can put it all in there, and then as you make your satellites, it's going to run them all for you, okay? So yep, you can totally use those. Okay, that's me on YouTube. I'm at Layla Codes It. So you can go on there. I've got videos on the one on architecture tests is, oh, I'm on the wrong screen. Oh no, how do I get to the, that one? No, I'm stuck on the bottom screen. Sorry, here, no. No, it's a new laptop, so I don't know. I've got 2 screens here. So anyway, it's that one, the second one, Banish Spaghetti Code, all right? So you can go and check that one out. I go fully in depth into architecture tests. And then finally, this is what AI thought I should look like, some creepy weirdo. So I thought I'd finish with that. And I used Dream Studio for nearly all of those images. I don't know about Dream Studio. Maybe Nightmare Studio would be better, but you know. You can get me on Twitter and YouTube on Layla Codes It, Layla-P on GitHub, and for everything else, layla.dev. So thank you very much for your time. I didn't do the Slido thing. You can come and find me out there if you have questions. And yeah, enjoy the rest of the conference. Thank you.